Manorama Yearbook 2024. India and the World. Number 1. Unfolding an era of India's space odyssey. First Indian to reach the moon by 2040. S. Somnath, Chairman, ISRO, Secretary, Department of Space, Chairman, Space Commission. India's space program is poised to reach new heights in the coming years. This article explores India's ambitious and successful missions that have earned it a place among the world's leading spacefaring nations. With a deeper understanding of the cosmos, India has embarked on a new era of space exploration. Over the decades, leveraging its key resources, Indian Space Research Organization, ISRO, has made several strides and has been on an incredible journey of exploration and discovery, propelling India to the significant mark on the global space stage. With every mission launched and every discovery made, ISRO reaffirms its position on the global stage as a force to be reckoned with, instilling national pride and expanding India's technological nest. In this article, we delve into unfolding various dimensions of ISRO's space odyssey, with a comprehensive look at some of the ambitious ongoing and upcoming missions like Small Satellite Launch Vehicle, Reusable Launch Vehicle Program, the historic lunar mission Chandrayaan-3, the en route Aditya L1 mission dedicated to exploring the Sun, the eagerly awaited manned mission Gaganyaan, upcoming X-ray astronomy mission XPOSAT, space docking experiment, quantum mission, LOX Methane Engine, among others. Together, these transformative initiatives define a new space saga in India's pursuit of space exploration, fostering scientific progress and an ever-expanding cosmic horizon. Small Satellite Launch Vehicle SSLV, Quick Launch on Demand. Small Satellite Launch Vehicle SSLV, developed by the ISRO, stands as a testament to organization's vision of democratizing access to space. Derived from its predecessors, the 34-meter tall, 2-meter diameter SSLV vehicle is configured as a 3-stage launch vehicle with 3 solid propulsion stages and liquid propulsion-based velocity trimming module VTM as a terminal stage, and is capable of launching 500 kg satellite into 500 km planar orbit in a quick turn around time TAT, flexibility in accommodating multiple satellites, launch on demand feasibility, minimal launch and infrastructure requirements, and importantly, low cost. With 2 flights in the recent past, SSLV is at a stage of transition from developmental flights to operational flights. Reusable Launch Vehicle RLV, low cost access to space. Following the success of SSLV, PSLV, GSLV, and LVM3 launch vehicles, India's foray into the Reusable Launch Vehicle RLV era emphasizes a commitment to development of technologies for winged reusable vehicle technologies. In 2016, the country achieved the first milestone of the RLV program in hypersonic flight experiment, in which the winged body vehicle was launched at hypersonic speed and safely splashed down in the sea. Building on this success, in 2023, autonomous RLV landing experiment RLV-LEX demonstrated the same winged body's release from an IAF Chinook helicopter at 4.5 kilometers altitude. With closed-loop guidance, it achieved a precise and record-breaking runway landing in Chitradurga, Karnataka at 325 km/h within 20 cm of the center line. The upcoming orbital re-entry experiment involves an orbital re-entry vehicle that will be injected into low Earth orbit, staying in orbit for a predetermined period, re-entering atmosphere and landing safely on a designated runway. Chandrayaan-3. India is on the moon. The success of Chandrayaan-3 missions stands as yet another laurel to the nation, charting a course for future Chandrayaan missions. In a historic achievement, Chandrayaan 3 earns national acclaim, leading to the declaration of August 23rd as National Space Day in India by the Honorable Prime Minister, with objectives including safe lunar surface landing, rover mobility, and in situ scientific experiments. The Chandrayaan 3 mission comprises indigenously built lander module for safe landing on moon, rover for roving on lunar surface, and propulsion module for powering the lander to lunar orbit. Launched by LVM-3 M4 launch vehicle on July 14, 2023 from CDSC Shar Shri Harikota, Chandrayaan-3 executed precise Earth and lunar maneuvers, achieving a historic soft landing near the lunar south pole on August 23, 2023. This success establishes India as the fourth country to master lunar soft landing technology and the first to land near the lunar south pole in the region between the Manzinus Sea and the Simplinus N lunar craters. In the mission life of 14 Earth days, Chandrayaan-3 yielded valuable lunar data, discovering aluminium, calcium, iron, chromium, titanium, sulfur, manganese, silicon, and oxygen in lunar soil. The temperature gradient of 60 degrees Celsius over 8 cm of 8 lunar regolith was observed. In situ measurements of lunar plasma and on-site tracking of surface vibrations caused by rover and payloads were conducted in the South Polar region. Just before the end of mission life, Vikram lander hop-on test was conducted successfully. Both Pragyan rover and Vikram lander were commanded to sleep mode after successful completion of all mission operations. Recognizing the stellar achievement of Chandrayaan-3, Honorable Prime Minister of India has named the landing site of Chandrayaan-3 lander as Shiva Shakti Point, while the landing site of Chandrayaan lander as Tiranga Point. Aditya L1, the maiden mission to study Sun. ISRO embarks on a solar exploratory mission, Aditya L1, dedicated to studying the Sun from the unique vantage point of Lagrange Point 1, showcasing countries' prowess in both lunar and solar research. Aditya L1, India's first spacecraft dedicated to solar observation, is strategically positioned at Lagrange Point, ensuring continuous and uninterrupted study of Sun's photosphere, chromosphere, and corona. This unique orbital location minimizes the need for orbital maintenance efforts. Lagrange points are unique locations in space where the gravitational force of two massive bodies like Sun and Earth precisely equals the centripetal force required for a small object to move with them. Or in other words, Lagrange points are equilibrium points in space where the combined gravitational force acting on all the small object exactly balances the centrifugal force felt by the small body. For any combination of two orbital bodies, like Sun-Earth and Earth-Moon systems, there are 5 Lagrange points, L1 to L5, of which 3, L1, L2, L3 are collinear and 2, L4, L5 are triangular points, also called Trojan points. Laden with 7 scientific payloads, all developed indigenously in collaboration with various ISRO centers, DOS unit, and academic institutes, namely Indian Institute of Astrophysics, 12A, Bangalore Inter-University Center for Astronomy and Astrophysics, IUCAA, Pune, Aditya L1 spacecraft is set to discover mysteries of Sun, including measuring of solar corona, solar wind, solar flares, and interplanetary magnetic fields at L1 point. Launched on September 2, 2023 by PSLV C557, Aditya L1 has escaped the sphere of Earth's influence and spacecraft is on its intended path towards Sun-Earth Lagrange Point 1 L1, approximately 1.5 million kilometers from Earth, where it will be inserted into a halo orbit in January 2024. Aditya L1 spacecraft will orbit around L1 in a periodic halo orbit with an orbital period of about 178 days. Upon insertion into the halo orbit around L1, Aditya L1 is poised for a 5-year mission contributing to valuable insights to our understanding of our nearest star. Gaganyaan, the human space mission of ISRO. Looking ahead, ISRO aims to take the next step in space exploration with the Gaganyaan program, planning to launch a crew of 2 to 3 Indian astronauts into low orbit LEO for up to 3 days before safely returning them to the predefined site in Indian waters. Aim at sending Indian astronauts into space, inaugural manned space mission, Gaganyaan involves developing critical technologies including a human-rated launch vehicle, life support systems, and crew management aspects. Precursor missions including integrated airdrop tests and pad abort tests, test vehicles flights, Gaganyaan experimental mission, 2 identical uncrewed mission precede the manned mission, showcasing India's commitment to safety and reliability in human spaceflight. The mission consists of human-rated launch vehicle and an orbital module comprising a crew module and a service module, SM. CM is the habitable space with Earth-like environment in space for the crew and designed for safe re-entry. Safety measures include a cruise escape system for emergency situations. Human safety is paramount, and various technologies, including IADT and propulsion tests, ensure human safety. 4 test pilots from Indian Air Force were selected as astronaut designates ADS for Gaganyaan mission. Currently, they are undergoing mission-specific training at Astronaut Training Facility ATF in Bengaluru. The first developmental flight of test vehicle was launched on October 21, 2023, and it successfully demonstrated in-flight abort of Crew Escape System CES at 1.2 Mach number, followed by crew module separation and its safe recovery from the Bay of Bengal by Indian Navy. The success of this test flight was crucial for subsequent qualification tests, unmanned missions, and the ultimate human space mission, expected to be launched in 2025. The excitement continues. Apart from the aforementioned breakthrough missions, strides in space technology continue in the thrust areas of astronomy mission, XPOSat, space docking experiment, quantum communication, air-breathing propulsion, LOX Methane Engine, etc. Planned to launch in 2023 to 2024, XPOSat X-ray polarimeter satellite is India's first dedicated science mission which will investigate bright astronomical X-ray sources in extreme conditions by using 2 scientific payloads capable of measuring polarimetry parameters, elucidating the degree and angle of polarization in X-ray photons of astronomical origin. Given the complex nature of emissions mechanism for celestial bodies like black holes, neutron stars, pulsar, wind nebulae, XPOSat's polarimetry measurements by adding dimensions of polarization degree and angle alongside spectroscopic data represent a significant avenue ahead for understanding intricacies of astronomical emission processes research. SpaceX, which is Space Docking Experiment, is yet another twin spacecraft mission dedicated to advancing orbital rendezvous, docking, and formation flying technologies with scope of applications in human spaceflight, in orbit satellite servicing, and other proximity operations. The mission involves two mini satellites, one designated as a chaser and the other as a target, launched together as co-passengers. Operating in slightly different orbits, the mission aims to docking will be demonstrated in the orbit. The success of the docking experiment holds significant importance in paving the way for lunar sample returned missions under future Chandrayaan missions. SpaceX is planned for launch in the third quarter of 2024. It is worth noting that for the first time in the country, ISRO achieved breakthrough demonstration of free space quantum communication over a distance of 300 meters using prepare and measure protocol and quantum entanglement protocols. A number of key technologies were developed indigenously to accomplish these technology feat, including entangled photon source, polarization compensation technique, gimbal mechanism systems, cryptographic software suite. ISRO is also planning to demonstrate satellite-based quantum key communication from satellite to ground stations and satellite to satellite in near future. The ongoing development of LOX methane engines, liquid oxygen oxidizer, and methane fuel engines is another game-changer future technology. This advancement holds the potential to facilitate human exploration of environments on other planets such as Mars and supports in situ resource utilization of celestial bodies. Methane is a potential space fuel that can be synthesized using water and carbon dioxide in space and plays a key role in enabling these innovative capabilities. Air-breathing propulsions with reusable capabilities is yet another key technological for cost-effective futuristic space transportation system. ISRO is actively pursuing development of technologies for air-breathing two-stage to orbit ABTSTO vehicle under air-breathing propulsion project. A significant milestone was achieved with the successful demonstration of scramjet operation in-flight conditions during ATV DO2 scramjet demonstration flight. The current emphasis is on critical technology development for integration of a scramjet engine into a vehicle called Hypersonic air-breathing vehicle with airframe integrated system. Successful engine testing was accomplished in 2022. In the wake of stellar achievements and incredible developments, including the recent Chandrayaan-3, Aditya L1 missions, and upcoming Gaganyaan mission, the future holds the promise of continued exploration beyond Earth's boundaries, with ambitious goals set by Honorable Prime Minister, including commissioning of Bharatiya Antariksha Station, Indian Space Station by 2035, sending first Indian to the moon by 2040, and embarking on interplanetary exploration, featuring a Venus orbiter mission and Mars lander to further solidify India's presence on the global space stage. As ISRO continues to push the boundaries of space and exploration with a foray of missions, we find ourselves on the cusp of an exciting and transformative era in India's journey through the cosmos, and the journey continues, with each mission weaving into the rich tapestry of India's space odyssey and highlights nation's prowess in space, science, and technological innovation, advancing our scientific knowledge, and serving as sources of national pride, demonstrating India's growing influence in the global space community.